Welcome to this video training lesson on the Browser Exploitation Framework, also known as BEEF. In this video, we will see how to automate the exploitation of a cross-site scripting vulnerability. If you thought that an XSS is just an alert window popping out on a vulnerable site, this lesson will completely change your mind. BEEF consists of a web server providing a hooking JavaScript script used to capture victim browsers and a web interface used to manage them. The tool is already installed on Kali Linux, but before launching it, it's better to harden the default configuration a little. Let's open a terminal shell and change the directory to etc beef-xss. Then we can edit the config.yaml file. The first setting we are interested in is the permitted UI subnet. We configure it to accept connections only from the local machine. It would be a terrible idea to let other people use BEEF to manage our victims. During an engagement, you also need to set the permitted hooking subnet to make sure that you will get control only on browsing sessions coming from a network included in the scope of engagement. The second option we're going to change is the listening port. Most corporate firewalls enforce policies on outbound ports. Most of the time, the ports allowed are just the ones needed for web browsing and work-related applications. This means that, as a rule of thumb, it is a good idea to have BEEF listen on port 80 or port 443. Remember to check if you already have other daemons listening on the port you want to use before setting it up. Here, you can also set a username and a password for the user interface. For this video, we will leave the default ones. You can start BEEF by going to the Applications menu, Kali Linux, System Service, BEEF, BEEF Start. But we suggest that you run it directly from the command line. You will see why near the end of the video. So we switch to the terminal shell, change directory to user share beef-xss, and launch BEEF. To access the user interface, we just have to copy the UI URL for one of the network interface cards installed on our machine and paste it in the browser. Please note that we configured BEEF to accept connection to the user interface only from the local host. We log in by entering BEEF as a username and BEEF as a password. To capture some browsers, we need them to run the hooking script, which is hosted on the public IP address of our machine at /hook.js. By injecting this script via a cross-site scripting vulnerability, we will establish a connection from victim browsers visiting the page to our BEEF server. Browsers will listen for commands sent by us and execute them. Let's inject the hooking script in this vulnerable page. We simply create a script object which has beef-hook.js as source. Switching to the BEEF console, we notice that the Online Browsers branch in the left column gets populated with our own browser. This happens because we just injected our payload and then executed it. But to test BEEF in a more realistic setting, we need to hook a browser on another machine. So we switch to a Windows machine and open the page containing our stored XSS. As you can see, the browser is detected by BEEF. We can immediately see that it's installed on a Windows machine and the connection source IP address. Please note that this could be just the public address of the network, where the victim machine sits, not its own IP address. If we click on the hooked browser, we can see information about the user agent, installed plugins, and its window size. We can also see what browser components are installed and information about the operating system. The most interesting tab is the Commands tab. Here, you can launch different scripts, called command modules, against the victim browser. Please note that every command has a colored icon on its left. A green icon means that the command will be invisible to the user. An orange icon means that the module could be invisible to the user. A gray one tells us that the command has not been tested against the target we are working on. And a red icon means that the command could not work in the victim browser. Let's see some command modules in detail. If we want to detect if the machine has a pop-up blocker enabled, we just have to click on the Detect Pop-up Blocker command and then click the Execute button. As you can see, the module result history tile has a new entry. To check out the command results, we just have to click on it and wait for the command to complete. The pop-up blocker is enabled. The next command we're going to run is in the Browser Hooked Domain branch, and it's the Replace hrefs module. With this module, we can replace all the hyperlinks of the page the victim browser has loaded with a URL of our choice. We test it with http://hacker.site. After waiting for the command to complete, we switch to the victim machine to see that, if we hover the mouse on any link, it points to hacker.site. Another thing that we can inject is a redirect to a page under our control. For example, with the Redirect Browser Rickroll, we can perform a Rickroll on our victim. And then we can redirect it again on the vulnerable page. We have complete control over the browsing session. The same thing can be done with an iframe, so we can give users the impression that they are visiting a certain website while they are still under our control. Beef is also a very valuable tool to perform information gathering. By expanding the host folder, we get access to commands which let us detect if the browser is running into a virtual machine by looking at the screen resolution. Please note that this could lead to false positives. Get the machine internal IP address by creating a Java applet on the fly and using it to detect the machine address. Do the same via HTML5 WebRTC. Another great resource is the Social Engineering branch. You can use it to inject any content you want in the current page. For example, we can make it look like a Google account login. And get a pretty convincing page. You could also inject a fake Flash update. Or a browser-specific fake notification bar. Think about the possibilities that this module could give you in a targeted phishing attack. You would just need to clone your target application login page and then wait for some stolen credentials. Before concluding this video, we would like to talk a little about how Beef identifies hooked browsers. When a browser runs hook.js, it will also install a cookie provided by the Beef server. This is used to identify single browsers across different sessions. For example, if we close the browser on the Windows machine, we can see that it's moved in the Offline Browsers folder. Then, if we open it again, it is moved back to the Online Browsers folder. This can happen because Beef can identify a single browser. All the information about different browsers and the domains where they were hooked is persistently stored in the Beef database. To clear this data, you have to run Beef with the -x command line switch. If we switch to the command line, press Ctrl-C to stop Beef, and then run it again with the -x command line switch. Beef clears the database. This means if we refresh the web interface and log in again, we will be prompted with a brand new empty session until a victim browser gets hooked again. Beef gives us a great way to automate cross-site scripting exploitation. Once you inject the hooking script in a vulnerable web page, you get complete control over what users see and their browsing session. This can be used to perform information gathering, mount targeted attacks against an organization, use a browsing session for an entry point during a penetration test, and to steal credentials and private information via phishing. For example, what would happen if an attacker found an XSS in a corporate website and made an unrelated page look like the webmail login? They would collect tens and tens of login credentials. As you studied in the course, cross-site scripting vulnerabilities give you control over a victim's browsing session. By using some creativity and the right tools, you can bring the exploitation of such vulnerabilities to the next level. And this concludes our video on the Browser Exploitation Framework. Thank you very much for joining us.